Happy Friday, everyone. Okay, we are on page 33. So, once again, your headphones should be on. I hope you aced your zeros test. Here we go. It says circle any equivalent ratio from the list below. So remember equivalent ratios, we can show their equivalent by putting in a tape diagram. Okay, so that's one way we could show that they were equivalent. That was one way. So we were going, okay, I'm going to make this 2. 1 to 2. Okay, so this is the ratio 1 to 2. What can I put in the 1 spot to get a 5? Well, 5. Are they equivalent? Yeah. I could also maybe put a 6 in. I don't know. Okay, because that's the first one. 6 plus 6, does that give you 16? Nope. So far only these two are equivalent. And next is 12. So if I put a 12 here, a 12 here, and a 12 here, this one gives me 12, but 12 plus 12 is 24. So that is not equivalent. So these two are equivalent. We can also find out if they're equivalent by making a table. So I could go 1 and 2. And I could count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I wanted to get to 12, but I guess we already know they're not equivalent. So I'm going to erase this and stop at 6. 2, 4, 6, 8, 10, 12. So 1 and 2 are equivalent. 2 and 5 and 10 are equivalent, but 6 and 16 are not. They're not lining up. The other way we could tell if they're equivalent is if we did 1 to 2, and then 5 to 10. So 1 times what gives me 5, 5, 2 times what gives me 10, 5. They both are getting multiplied by the same number, so they're equivalent. So I want you to just pause the video real quick and see, is 6 and 16 equivalent to 12, 32? So you might want to use the tape diagram. You'll have to build another one because you have to have a 6, 16. You might want to make a table, or you might want to do it mathematically. But at this time, pause the video. When you're ready, push play. Okay, so if you did the tape diagram, you would have had something that looks like this. And you would have 16 here, which is a lot. There's 4, 8, 16. So I would say, what do I have to put in all these 6 boxes to get 12, for this to be 12? What number can I multiply by 6 to get 12? 2. So if I put 2 in all these boxes, would I get 32? So essentially, I'm going to be adding 2 16 times. If you can't do 2 times 16, just go 2, 4, 6, 8, 10, 12, 14, 16. And you'll see that you do get 32. Okay? You might have made a table. If you made a table, you would go 6, 16. Your next one would be 12, and then 32. And you might have done it mathematically. 6 to 16, 12 to 32. 6 times what is 12? 2. 16 times what is 32? 2. And because these two are being multiplied by the same number, they're equal. So we are going to find the value of these ratios. So finding the value of these ratios means that you're going to leave your answer as a fraction, but these fractions is going to be in simplest form. Okay. So for example, the value of the ratio, the value of 1 to 2 is 1/2. But the value of, and I'm going to run out of room because you know how I hate how Eureka does it, 5/10, 5 to 10. I can write it as a fraction like this, but it's not in simplest form. What number could I go from 5 to 10? What number goes into 5 and 10? Well, 5 goes into 5 and 5 goes into 10. So the value of this ratio is a half. Your next number is 6. I'm going to even write it further out here. 6/16. Well, I look at this number and I see, they're both even. What number goes into any even number? Well, that's 2. 2 goes into any even number. Whatever I do to the top, I have to the bottom. 6 divided by 2 is 3, and 16 divided by 2 is 8. Your last one as a ratio, and I have room down here, I would write 12/32. So I have to think, what number can go into any even number? Well, 2. So I'm going to divide the numerator and denominator by the same number. 12 divided by 2 is 6, and 32 divided by 2 is 16. Well, once again, I have even numbers. I already actually did this right here. So that means that they're 3/8. What do you notice about the value of equivalent ratio? You got to write this down. The value of the ratio is the same for equivalent ratios. So what does that mean? That's supposed to be a period. These two are equivalent ratios. Their value is the same. And these two equivalent ratios have the same value of 3/8. So the value of the ratio, these are the values, are the same for equivalent ratios. So then they give you this like little jargon. Make sure you pause and write that down. They give you this little jargon, and it says this. Here is a theorem. If A to B, where B does not equal 0, and C to D, where D does not equal 0, are equivalent, then they have the same value. That's exactly what we just said up here. This is essentially stating that if two ratios are equivalent, then their values are the same. So can we prove that this is wrong? No, it's completely true. That is a true theorem. So we're going to turn the page. We're going to go on to page 34. It says, Tavon is training for a duathlon. Duathlon? It's when a person competes in two events. Normally it's running and biking, running and swimming, one of the two. So which is race that consists of running and cycling? Oh, running and biking right there. Now I know. The cycling leg is longer than the running leg. As in, when we say leg, we mean that they cycle for a longer distance than what they run. So while Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every, which is a key word for like 14 miles he rides his bike. Identify the ratio associated with the problem and find its value. So the ratio is 4. Remember, for every is like 2. And we have 14. We are going to then write this as a fraction, 4 to 14. And we think in our head, what number, these two are even numbers, what number, I always ask myself that, are these two even numbers? Because so many times we can simplify fractions just looking and saying, are those even? If they're even, we can divide by 2. So these are both even. What number goes into any even number? 2. Whatever I divide the top by, I have to divide the bottom by. So I have 4 divided by 2, that's 2, and 14 divided by 2 is 7. So the value is 2/7. So it says use the value of each ratio to solve the following. When Tavon completed all of his training for the duathlon, the ratio of total number of miles he ran to total numbers of miles he cycled was 80 to 280. Is this consistent with his training schedule? Explain why or why not. Well, if it's consistent, if this ratio is equivalent to this ratio, they have the same value. So we are going to simplify the fraction 80 over 280. Okay, so if you remember from Wednesday, I told you the super fast way to simplify fractions, if they both end in a 0, was you could cross one off. So if 80 has a 0 at the end, I cross it off. And 280 has a 0 at the end, I cross it off. That leaves me with 8 over 28. Now it's not simplified all the way, because right away I see in my head, oh, these two are even. So if you're like, I have no clue what she means by even, okay? Even, and we need to know what evens are. Evens are any number that ends in 0, 2, 4, 6, or 8. Those are even numbers. If when I count by 2s, I get to that number, it's even. So 2 could be divided by both of these. 8 divided by 2 is 4. 28 divided by 2. Well, 2 divided by 2 is 1. And 8 divided by 2 is 4. Oh, they end in 4s. They're both even. I'm going to divide each of these by 2. 4 divided by 2 is 2. And 14 divided by 2 is 7. So they both have the same value. So I'm going to write, my question is this consistent? This is consistent because the value of both ratios are the same. In one training session, Tavon ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? So I have 4 to 7. I'm going to write that as a fraction, 4 to 7. They're not both even, so I can't simplify that way. So the only numbers that can go into 4, the only time I can get 4, 1 times 4, 2 times 2. 7s, 1 times 7. The only thing they have in common is this 1. If I divide these both by 1, you don't have to write this down, but if I divide these both by 1, I still get 4, because 4 divided by 1 is 4. 7 divided by 1 is 7. So this has a value of 4 sevenths. This has a value of 2 sevenths. They are not equivalent because their values are not the same. They are not equivalent because the values are not the same. So, what you're going to do now, once you have this all copied down, you are going to shut your laptop. And you are going to read until your shoulder partner, the person sitting next to you, has their laptop closed. So when both of you guys are done with your lesson, then you are going to do the problem set 1. So let me just show you the problem set. You're doing 1. You're going to do 2. Use the value of the ratio to determine which ratios are equivalent to this. You can circle which ones are equivalent. So this one is multiple choice. You can choose that. So maybe right on your side, this is multiple choice. I know I normally tell you they're not. This one is. Okay, 3, you're going to do A, B, C. And then 4, you're going to do with your shoulder partner. Okay, so you're going to do this with your shoulder partner when you're both done. And I will see you hopefully Monday. Talk to you later.